Is it clear? So alcohols and ethers, right? So alcohols and alcohols can be classified further into aliphatic alcohols. And aromatic alcohols. Right? What are aliphatic alcohols? Yeah, tell me. Yeah, Karthik, can you hear my voice?
Hello, sir. Yes.
Yeah. So we just started with alcohols and ether chapter. So what are alcohols and ether? That's what I was telling.
Okay, sir.
Alcohols are actually on oxygen. You have one side alkyl group. Alkyl group generally it is represented by R. It can be methyl, ethyl, propyl. Okay. And suppose if you have alkyl groups on both the sides of the oxygen, that is going to be an ether. Okay.
Yes, sir.
And alcohols can be classified. This is an ether, right? So, or let me move it here. Alcohols can be classified further into aliphatic alcohols and aromatic alcohols, right? And this is going to be an ether. So, what are aliphatic and what are aromatic alcohol? Yeah, Iman, Priyan. What's the difference between aliphatic and aromatic? Karthik?
Aliphatic alcohols are organic chemical compounds.
Aliphatic alcohols are?
Organic chemical compounds.
Yeah. Organic chemical compound connected to normal alkyl group like methyl, ethyl. Okay. So you can have a normal, suppose methane is CH4. So in order to put O, Rayan and Karthik, you need to remove one hydrogen. You need to make it CH3 and you need to put OH.
Yes.
CH3 and CH3, CH, 2OH. This is ethyl alcohol or ethanol. CH3, and this is all of these are normal alkyl groups. The alkyl group can be a straight chain or it can be a branched. Okay, is it clear? So what kind of alkyl group, what kind of alcohol is this one? You can classify, yeah, it is tertiary. It is tertiary, right? And
Yes.
what kind of alcohol is this one?
Secondary.
Yeah, secondary means
2
the,
degree.
yeah, the carbon on which the OH group is present is actually connected to 2 carbon atoms, right? That is secondary. And this one is primary, 1 degree or primary. Okay. And this one is not any of these because it is not connected to the carbon on which OH is present is not connected to any carbon. Is it clear?
Yes.
And what are aromatic alcohols? Priyan and Iman, tell me. Aromatic alcohols are also organic compound having OH group directly connected to benzene. Okay. There are many other aromatic rings also, but the benzene is the most common. So what is the common name and IUPAC name of this?
Phenol.
Yeah, phenol. Exactly. But there can be other type of aromatics ring also, but this phenol is the most common. Right? Is it clear?
Yes, sir.
Yes, sir.
Imad and Rayan.
Yes, sir.
So alcohols can be classified on the basis of the number of OH group also. Suppose if you take this alcohol or if you take this alcohol. Anushka, can you hear me? This just we started with the classification of alcohols. So what kind of classification is this one? Yeah. Any idea? Yeah, Karthik, Rayan, Imad, Anushka, tell me.
Sir,
So what
is
is
it
the compound?
This one is
polydiandrite?
this is monohydrate.
Yes.
Monohydrate means one OH. Okay. What about this one?
Di.
Yeah, dihydrate alcohol. This one,
Tri.
okay. So this classification depends upon whether you have one OH group, two OH group, three OH group. Okay. Based on that, you have classified. Okay. The next thing is which classification is this one? Dihydric alcohols are known as diols. Diols means two OH groups, right? So both of them are diol. But what kind of diol are they? Yeah, Anushka, can you hear my voice?
Yes, sir, I can hear.
Yeah, which type of diol is this? And first one and the left one and the Karthik, which diol is right one? How do you classify them? If two same groups are present on adjacent position, adjacent carbon atom, then you call it vicinal. Okay, so this is vicinal diol. In short, VIC. And what about this one? Himad?
Geminal.
Yeah. Geminal means two same groups connected on the same carbon atom. Right?
Yes, sir.
Actually, one more thing. Gem diols are unstable. This is some extra thing. Gem diols actually you don't find, okay, because they are unstable. They release one water molecule. So what I will do, I will pick OH and H and I will remove water. So this is how we are going to. Gem diols are unstable, they release H2 molecule and they get converted to C double bond O, aldehydes or ketones. Is it clear to everyone? Very basic thing, very important. Imad, Karthik, Rayan, is it clear?
Yes, sir.
Anushka? Okay.
Yes,
So
sir.
this is the basic classification. Now the next thing about the classification of alcohols is the next part is the nomenclature. Okay. So what is going to be the name of yeah. Yeah, what's going to be the name of these two alcohols? Yeah, you can try quickly. Who's going to tell me? Rayan, Karthik,
Sir, 1,2,2 methyl propanol.
1,2. Should I start numbering from this side
No, sir. From OH.
or from the side which is nearer to the principal function group?
Sir, side which is nearer to principal.
Yeah. So Anushka, you can write. You need to do the numbering from one end to another end. But it should start from the end which is closer to the function group. So this is correct. Right? And the white one was wrong. Numbering. Okay. So what's going to be the name of this first molecule? Hemar. Numbering we have done. Yeah, tell me.
Tetraco.
Yeah. So first of all, we should count the number of carbon atom in the main chain, and they are
Yeah.
4.
Yeah.
So but for 4, ane, and on second carbon you have OH butane 2 all. Right?
Yes, sir.
And this is only the main part. What about the 2 methyl groups which are coming out? So that is going to be
3,3 methyl.
3, yeah, 3,3
Methyl.
dimethyl.
Yes, sir.
Dimethyl. 3,3 dimethyl butane 2 all. For every side chain, you need to write the number. But if the groups are same, you will not write them as methyl and methyl. You will use numerical prefixes di, tri, tetra to indicate their numbers. Okay. And what about this one?
So numbering from right side.
Numbering from
Right side.
the right to left. Yeah. So what's going to be the name of this?
Sir, but 3 in 1 all.
Yeah, 4 carbon atom are there. In and all, because O is vowel, so I'm going to remove the E. Okay, this is going to be the answer, right?
Yes, sir.
So what's the IUPAC name of this compound? Yeah, you need to select the longest chain. Anushka, can you hear my voice?
Yes, sir.
Yeah, longest chain is the one which has maximum number of principal functional groups. And which is the principal functional group? The principal functional group is the OH itself. Okay. So one more thing, that is either you are going to choose the outer chain or the cyclic chain. Okay, if there is an open chain or a cyclic chain, both are present, you will choose the main chain as the one which is having the principal functional group, which is OH. Right? So Karthik, I am choosing my main chain as this one. Is it clear? Ryan? It is because my main functional group OH is connected on this. That's why I've chosen this as the main chain. Okay. So what's the name of this, Imad? This portion? First, you need to do the numbering.
Okay.
Okay. But while doing the numbering, while taking the chain, don't take the benzene. That is a cyclic one. But I have not taken benzene as a parent chain because the OH is connected on my open chain. So I have taken open chain as my parent chain. Is it clear or not?
Yes, sir.
Right? So yeah, tell me what's going to be the name of this compound?
Butane wall.
Yeah, so this is propanol, propane 2-ol. I will do the numbering from this side. Actually, this side or that side will not be a matter of concern for OH because it is on the second position, it is in the middle. But it is a matter of concern for benzene. So you need to keep the number such that the benzene also get the lowest number. Okay, first priority is given to the OH. Then you give the priority to the benzene. So propanol, right? Propane and propanol where the ol is present, 2-ol. Okay, propane 2-ol. And this is for the OH where the benzene is present.
Sir, it is connected with first carbon.
Yeah, so I'm not calling it as a benzene. When the benzene is a substituent, I call it as a phenyl. Is it clear? 1-phenyl propane 2. Is it clear?
Yes, sir.
Yes, sir.
And what about the second molecule? What's the name of the second molecule?
Sir, 4-diethyl.
Yeah. So
3-methyl
Yeah.
cyclobenzenol, cyclohexanol.
Yeah, this is not benzene. The
Yes, sir.
benzene has 6 carbon and there are alternate double bonds. Okay. This is
Yes.
cyclohexane. Okay. So I will do the numbering from my principal function group 1, or should I move right side or left side while doing the numbering of the cyclic chain? I should move such that the alkyl group, the substituent, get the lowest numbers. First priority is given to the principal function group, that is OS. Then I use to give the low priority to alkyl groups. Okay. So this portion, the parent chain, including the function group MEI, is cyclohexanol. It has 6 carbon atom, okay, and the OH. So, but it is cyclic. So cyclohexanol. Okay. And what about this? On 4 you have ethyl. On 3 you have methyl. Cyclohexanol. Right?
Yes,
Clear
sir.
to everyone?
Yes, sir.
Okay. And what's the name for this? The common names are also important. Yeah.
One is ortho. Um, First one is ortho, second is para, and second is meta, and third is para.
Yeah. Suppose if this is the benzene ring, this is only on the benzene. This is benzene, not on cyclohexane. Okay, guys. So on benzene, if you have a group, ortho positions are the positions which are adjacent to the group. Okay, both the adjacent positions are ortho. Next to adjacent is meta. And this is para. Ortho, meta, para. Right? Is this clear?
Yes, sir.
Yes, sir.
So this is ortho, meta, para, but this ortho, meta, para is a common way of naming the structures. Because in IUPAC we give the numbering. Okay, and there is another specific common name, that is catechol. Catechol, the meta one is known as resorcinol. These are also the common name. And this is quinol or hydroquinone. Okay. The IUPAC names are not ortho, meta, para. They use the numbers. So this is benzene 1,2-diol, benzene 1,3-diol, and benzene 1,4-diol. Is it clear?
Yes, sir.
Yes, sir.
So these are actually the IUPAC. So IUPAC name are very formal, okay, and they are always governed by the set of rules. Okay. Now the next thing is, what about ethers? Ethers are the functional group, ethers are functional isomers to alcohols, and they have oxygen, singly bonded oxygen connected to alkyl groups on both of their sides. So what's the name of this ether?
Methoxymethane.
Yeah. Ether actually support the rules are IUPAC rules are same. They are very uniform. So first you need to select the longest continuous carbon chain. Okay, that is your ethane. Okay. I've not chosen CH3. And one more important thing, ethers and halides, they are always written in prefixes, means before the name. They are always treated as substituents. Alcohol, if they are alone, they are written in suffixes. Okay. So what is the name of this prefix? This is oxygen and methyl. Yeah. So what you should call it? Methoxy. Yeah, methoxy. Right? And it is on the ethane. So just you have to write methoxy ethane. That's it. Is it clear?
Yes.
Okay. Here also you need to select the longest chain. Now what's going to be the IUPAC name of this compound?
Methoxy 3-methyl butanol.
And this is the principal function group 1, 2, 3, and 4. Yeah. Butane, right?
Yes, sir.
Butane 1 all.
3-methyl butanol.
Yeah. Can you hear my voice?
Yes, sir.
So yeah, what's the name? That's we were discussing. Butane 1-ol is the name of the parent chain and the function group, right?
Sir, shouldn't it 3-methyl butane monol?
Yeah, butane. We have named up to this point. This portion we have named by telling butane 1-ol. This is we have written, right? Okay.
Yes,
So
sir.
what about the remaining portion? Where is it?
Sir, 3-methyl.
3-methyl. And what's there on the second position?
Sir, methoxy 3-methyl
Yeah,
butyl.
2-methoxy. Imad, is
Yes,
it clear? 2-methoxy, Anushka, Karthik, Rayan.
Yes, sir.
Yeah. So 2 on second position you have methoxy and methyl. So which one should be written first? MET, methyl, METHY, methyl, and METHO. So O comes before. So I should write Karthik 2-methoxy, right? And 3-methyl. Is it clear?
yes, sir.
Butane 1-ol. Okay. So that's going to be the IUPAC name of this compound. So, but you should be very careful that if there is some other functional group which is having more priority, higher priority than the alcohol group, then the alcohol will be treated as substituents. Okay. Then they will be treated as substituents and they will be written as hydroxy. So, okay, so we will see that portion in your aldehydes and ketones chapter, where the alcohols are of low priority, so they are junior functional group and they will so be written in the prefixes. But as of now, alcohols are written as alls, okay, at the end of the name as suffixes, and ethers are always written as prefixes. That thing you should keep in mind. Okay, clear? So now let's move to the methods and preparation. So how can we prepare alcohols? So what's the common way of preparing alcohols? Yeah, Anushka.
Sir,
What is the yeah?
through alkyl halides.
Yeah, through alkalinide, but what we can do in we can proceed systematically. So from alkanes are almost non-reactive, so we can't get alcohol directly. So let's start from alkenes. Okay, so preparation of alcohols from alkenes. So alkenes have a double bond. So how can you get the alcohol from alkene? What could be the method? Yeah.
Sir, Markovnikov's rule.
Yeah, this is so I should say general way. That is the rule that is more in depth. So what type of reaction is this? Let's move from the top. Okay, basic thing first. Yeah, is it an addition reaction, elimination reaction? What kind of reaction is this? Yeah. or substitution reaction, Imad, or rearrangement reaction, Ryan.
It is substitute.
Substitution is one group is replaced by another group. And if two groups come and join, that is addition. If two groups are removed, that is elimination.
The nucleophilic.
Yeah, it is addition or substitution or elimination or what?
Addition.
Look here,
Addition.
what has, yeah, pardon?
Addition.
Yeah, this is addition reaction. And addition of what? Yeah,
H2O.
addition of water, right? Because you can see OH and H getting added. So it is addition of water. And so I should write plus water. Okay. This is one thing. Next thing is, you need to take some catalyst. Why catalyst? Why catalyst is necessary? Because simple water is not very reactive. We drink water, right? Why we are able to drink it? Because it's not reactive. So suppose if it is highly reactive, then we will not be able to consume water. And because it is very less reactive, it is neutral. So simple water, if you put, it will not react. So you need to take some catalyst. So which is this catalyst? Tell me.
H2SO.
Yeah,
Sulfate.
dilute H2SO4. Okay. So what this method is known as, Anushka? Overall, now we can, whatever we discussed, we can write it one by together.
Marconi coefficient.
And that is the rule. The method is known as acid catalyzed hydration of alkenes.
Yes, sir.
Acid catalyzed means because you are taking a dilute H2SO4 as a catalyst. Hydration means addition of water of alkenes. This is the method, and we are adding water. Okay, and this is governed how the addition take. What's the mode of addition and what by which rules govern this? That is Markovnikov. Anushka, is this clear?
Yes, sir. Understood.
It occurs through Markovnikov rule. Ryan, it occurs through Markovnikov. Okay. So H plus dilute H2SO4. It occurs through Markovnikov rule, and what the Markovnikov rule says, just quickly we can recap. The rich gets richer. That's the quick way to express it, shortcut way, and it means the carbon atom which has more number of hydrogen, there the H plus will go and get attached, and the carbon atom which is having less number of hydrogen, there the OH will get attached. Is it clear?
Yes.
Okay, acid catalyzed hydration, okay, of alkenes. So the major product is going to be governed by, so I'm going to put H over here and OH in this case, right? So why the Markovnikov rule is, why the addition occurs to Markovnikov rule? Now, what's the internal reason for it?
So the double bond is removed
Yeah,
and the carbon atom with a lesser number of hydrogen atoms is attached with the OH group.
yeah, exactly. So what happens here is, so first of all, H2SO4, you have taken that act as a catalyst. Catalyst is something which help the reaction to occur quickly, but it itself doesn't get consumed. H plus and HSO4 minus, right? And H plus will get attached to alkene, okay, on the H plus. Why H plus? Because H plus is an electrophile, it needs electron. And where can it get electron more easily? It's from the double bond, because double bond has two bonds, so it has more electron density, and H plus goes towards the double bond between carbon carbon. From there it gets the electron, it attaches itself to the carbon atom bearing more number of hydrogen. And the reason is, so this double bond is there, H plus double bond is there, like this. There is one more bond, there is double bond, H plus comes, right, and this H plus pulls the electron density out of the double bond, right, because H plus is not carrying its own electron, that's why it is plus. So it pulls the electron from the double bond, and now the double bond is out, okay, and you have plus on the middle carbon, okay. And then what happens? This is secondary carbocation, which is more stable. And now, because you have taken water, initially water was not able to react because it was neutral. So that's why we use H2SO4. So water is going to come and join. Water oxygen has some ideal pair of electron. They are going to come and join. And this is, and now H plus will be removed. That's how it has occurred. H plus, look, H plus was given initially and it was now taken back. That's why I'm calling it as a catalyst. Catalyst is something which is not, which will not get consumed. It will be regenerated, right? So let me give you some more examples. So I hope this is clear. This is H plus and H2O, right? It's another, both combined together, so it's the same thing. Okay, written in a different manner. This is nothing but H plus and H2O, same as that of dilute H2SO4. So what's going to be the answer to this problem? Write the major product of these reaction. IUPAC names also you can tell me. Dilute H2SO4. This DIL is the short form, abbreviated form of H2SO4. Dilute H2SO4. Yeah, what are we going to get? Yeah, Anushka, Himar. Yeah. This one, first one, where the H is going to come and join. Yeah, Anushka.
Sir, on CH2.
And OH in the middle, right?
Yes, sir.
And Karthik, so what's going to be the IUPAC name of this alcohol?
Sir, the product.
Yeah, product. So the parent
Sir,
chain is the outer chain, okay?
sir, phenyl. No, phenyl ethanol.
Yeah, one phenyl ethanol, right? Ethane one on, right? Correct. And what's going to be the what going to be the product of this second reaction, Ryan and Imad? So this is clear, no bond line representation. This CS3, this is CS3, this is carbon. Okay. Remember, everywhere you need to have 4 bonds on the carbon. Okay. This is the complete detailed structure. So where am I going to put the H? Plus, and where am I going to put the OH? Is it clear?
So how? Can you explain that?
Yeah. There is double bond, okay, between. So on the right carbon, there is 1 hydrogen.
Okay.
On the left carbon, there is no hydrogen because there are 2 carbon.
Okay.
So I'm going to put the H at the carbon on the carbon atom, which has already more number of hydrogen, and the OH on the adjacent carbon atom, right?
Okay.
So this is going to be HNO, okay? So what's going to be the answer to this? What's going to be the IUPAC name? So this is the main chain which I have selected butane to all. I will do the numbering from this side, butane to all, and 2 methyl butane to all.
So two butane
Yeah, 2 methyl.
methyl. Okay.
This one for this one. Butane to all. Right? Is it clear?
Yes.
And what about the third one? Yeah, Anushka. Ryan, Imad, Karthik. So here you need to have 4 bonds. So 2 are visible, the remaining 2 are hydrogens. Here you have 3 lines, 2 and 1. So 1 should be hydrogen because carbon make 4 bonds. Okay. So some of the carbon-carbon bonds are visible by lines. So count the lines. Suppose if there are 2 lines between 2 carbon-carbon bond, the remaining is hydrogen. Okay. So what we are going to do?
Left.
Yeah. Yeah, Karthik.
So left side H and right side OH.
Yeah, correct. And what we are observing after analyzing all the Markovnikov addition, what we are analyzing that OH is also will get connected on the internal carbon. Okay, because look here, it has connected. OH is connected not on the outer carbon, inner carbon where there are more carbon atoms. Okay, and hydrogen will come on the outer carbon generally. That's what we observe. Okay, so that is Markovnikov of addition. Is it clear, Imad?
Yes, sir.
Any doubts?
Yes, sir. How can you explain this third again? Because you just
Yeah.
marked CHOH. What
Yeah.
was that?
Actually, what I will do is, this is bond line representation, a short form of the whole structure. So what I will do this, I will write this structure in detail. CH2 double bond CH, CH2 CH3. Okay. And yeah, now we have H and OH need to be connected in this way, because this is Markovnikov, because we are putting the H on the carbon atom which is having more H and OH in the middle. So this is going to be the answer, right? Clear?
Yes, sir. Clear now.
Okay,
Yes, sir.
just one more we can try. This one. Yeah. So you need to check this carbon as how many bonds are visible to you?
3.
3. So
Yes,
that
sir.
means carbon has 4 bonds, so 1 is hydrogen. There is 1 hydrogen over here. That's how you can make out. And how many bonds are visible on this carbon atom?
You.
4. 4 lines are there, no? 1 going up, 2 going on this side, and 1. Okay.
Yes,
So
sir.
4 bonds are there. No hydrogen is there. Okay. Always the carbon is having 4 bonds, remember. And if 3 are visible, if 2 are visible, mean 2 are hydrogen, which are not written. Is it clear? Imad, is it clear? Rayan,
Yes, sir. Clear
Imad,
now.
right? So we are going to put the hydrogen on the carbon atom which has already more number of hydrogens, and the OH on the internal carbon. Where there is more branching, there you put the OH. That you can remember. No need to show H, because that get mixed up with the original H and we don't write the H in bond line representation. But for clarity, we can write. For clarity, we can write it like this. And this is the S, this is the OH. Okay. And that's how they are connected. So this is the alcohol, okay, which we are going to get. Anushka, Ryan, is it clear to you?
Yes, sir.
Now the next thing is, it is not always necessary. Suppose if I take butane. So if I take dilute H2SO4 and add water, okay. So H outside, OH inside, right? So that's how we got the alcohol. But OH is also always going to come inside. Is there any way? That was Markovnikov addition. Is there any way by which we can somehow put the OH on the outer carbon?
Sir, anti-Marconic.
Yeah, the way in which the pattern will be the anti-Markovnikov. Yeah. But this is the way by which the addition is occurring. But actually, what are the reagents?
Sir, H2O2.
No. Till now, we have seen anti-Markovnikov addition of HBr. Okay. We have seen how out of HF, HCl, HBr, and HI, we had a facility to put the HBr in two different ways on the double bond. One was Markovnikov fashion, another was anti-Markovnikov if you take HBr in the presence of peroxide. But the peroxide is not H2O2. Sometimes we may write, but that is not appropriate. We should write actually benzoyl peroxide. Or if nothing is given, it will work. So HBr, if it is taken in the presence of peroxide, then it is going to add in an anti-Markovnikov fashion, right? But for what addition of water, and if you want to attain that anti-Markovnikov addition, what you need to take? Simply H2O2 will not work. You need to take some other things also. Okay. So you need to take a set of reagents, and I'm like writing the list of sequence of reaction. Right? Is it clear?
Yes, sir.
So what this method is known as? I have written in a condensed way by putting number. Actually, this is a set of two steps. Okay. Actually, what you take, borane, BH3 is borane. Okay, or it is also written as B. It is dissolved in an ether which is known as THF. It is used to mix the borane. It is also known as B2H6. So first you put the borane, and that brings in the H and boron atom on the double bond. And then you oxidize the boron atom and you put OH in place of boron atom. So that is oxidation. So the name of this method is, this is the short form. But in boards, you should not write the short form. This is just for you guys so that you can remember it. So HBO. HBO is a movie channel. You might have seen it. Okay. But here we are not talking about the movie channel. This is just a mnemonic to remember. The full form is hydroboration followed by oxidation. Is it clear?
Yes, sir.
Hydroboration and oxidation. That's going to be the That's going to be the method by which you can do the addition of water in anti-Markovnikov fashion on alkenes. Imad and Rayan, is it clear?
Yes, sir, clear.
Hydroboration. Actually, how it happens, let me tell you quickly, very quickly, just. Actually, what happens here is, so you are not putting water directly, Karthik. What you are adding is boron. And
Yes.
boron, being a larger atom, will prefer to join on the outer carbon. Okay. This boron, the boron is larger atom, so it will not get connected inside, it is going to get connected outside. H and BH2. Right? And this method is known as, but actually it doesn't stop. Actually, this boron has 2 more hydrogens, so it keep on adding 2 more times. So don't get into the details. Just simply you can remember that boron is going to attach outside, hydrogen is going to attach inside, because boron is a larger atom. And larger atom needs more space. Okay. So hydrogen from the BH3 got connected inside, boron got connected outside. And now what we can do, we can oxidize this boron by NaOH and H2O. Is it clear? So, but you are not going to write all this. Okay, just write the set of reactions. That is going to be sufficient. So how you are going to make an alcohol? By doing anti-Markovnikov addition of water. How you are going to do that? Tell me. So what's the way? Suppose if someone asks you, Karthik,
Yes, sir.
what you will say? If I give you an alkene, and if I ask you to add water on that alkene in anti-Markovnikov fashion, what method will you adopt?
Hydroboration oxidation.
Yeah, hydroboration oxidation. Hydroboration oxidation you are going to get adopt. So this is suppose if we take direct H plus and H2 or dilute H2S4, what you are going to get? You are going to get the addition done in the Markovnikov fashion. Okay. And suppose if you would have taken Anushka BH3 or B2H6 also you can write. But actually BH3 in THF. THF is actually used to make the solution. And the second is this whole process comes under the name of hydroboration and oxidation, HBO, right? So what you are going to get? You are going to get the reverse thing. Actually, boron is going to connect itself outside because it is a bulky atom. So boron will be replaced by OH. And that's how we are going to get it. Is it clear? Right? Okay. And what are the other methods to prepare alcohol? This is from alkene. Yeah. From alkene and from alkyl halide. That's what Karthik said initially. Yeah.
Alkyl halide with aqueous KOH.
Aqueous KOH. That is by substitution reaction. Okay.
Yes.
Nucleophilic substitution reaction. In short, I have written substitution reaction. Okay, so suppose if you are having ethane, how will you convert it to ethanol? Yeah, tell me. So this is not an alkene where you can put directly water and so
Sir, RMG,
how?
Sir, Grignard reagent.
No, not Grignard. Actually, just remember one thumb rule. Okay, and it is going to help. I tell every day to all of my students. Okay, so that they can keep it in mind. Even my JE students, IIT students, okay, NEET students who are preparing, I tell them all the time. Okay, very basic thing. The thing is, whenever you start with alkane, if you see an alkane, this is applicable for all the chapters which you are going to do in organic. If you see an alkane, always remember, always do photohalogenation in order to proceed further. Is it clear, Anushka? Rayan?
Yes, sir.
Yes, sir.
While proceeding to any conversion starting from alkane, start by taking photochlorination, photobromination, in which you react alkane with Br2 or Cl2 in the presence of light. CH3, CH2, Br. Okay. And now once you have Br, now we can talk about this nucleophilic substitution reaction. So take KOH dissolved in water. That is going to be the aqueous KOH. OH minus is going to come in and join from the carbon, and in the nucleophile, wherever it goes, it pushes away someone, because nucleophile is having its own electron, its minus. So Br bond is larger and it is weaker, so it will be pushed out. Okay, this is nucleophilic substitution reaction. Is it clear?
Yes.
Yes, sir.
So how you are going to get an alcohol? You take alkyl halide, and from the alkyl halide you You carry out nucleophilic substitution reaction by using aqueous KOH, and that will push away the Br. Is it clear? Right?
Yes, sir.
Very simple thing. Very simple. Okay. So let me give you the conversion roadmap that will be very helpful. You can write it and always remember. Suppose if you take alcoholic KOH, then what was going to happen? And this is a thing which is useful in your alkyl halide chapter also. Imad, alcoholic KOH and heat. What are we going to get? Karthik, Anushka, alcoholic KOH and heat. What heat is going to do? It's going to eliminate. Okay.
Yes, sir.
And what we are going to get? We are going to get an alkene. That's what we studied in alkyl halide chapter. Aqueous KOH is mild and alcoholic KOH is strong, right? So it eliminates the HBr. And if you have an alkene, from alkene also you can come down to alcohol by taking dilute H2S. Is it clear? Imad, Anushka, Ryan, is it clear or not?
Yes, sir. Clear.
Karthik,
Clear, sir.
clear to everyone? So this is the method. Photohalogenation alkene, if you are starting from alkene, always start with photohalogenation. Bring in one alkyl group, and that alkyl group can easily be substituted by your OH group. This is toluene and Cl2H nu. This is photochlorination. So where the photochlorination is going to happen? Always on the alkyl group. Here there are two groups. One is alkyl, one another is aromatic. Okay. So BSCH2Cl. This is benzyl chloride. That's the common name. And if you are using KOH aqueous, the OH minus is going to substitute. Is this an aromatic alcohol or aliphatic alcohol? Karthik, Anushka, Imad, Ryan, tell me.
Sir, aromatic.
Aromatic.
No, this is aliphatic. Aromatic is this one. You need to check whether the OH is directly connected or is it connected to carbon, normal carbon. So the benzene ring is there. That was correct, that part. Benzene ring is there, aromatic ring is there. But the alcohol is not aromatic. Why is it so? Because the alcohol is not connected directly to the benzene. It is connected to the carbon which is outside the benzene. Is it clear?
Yes, sir. Clear.
Okay, so do keep this in mind.
How do we check that alcohol is aromatic or not?
Aromatic if it's the OH is connected directly to the benzene.
Okay.
Then
Because in
it's
this figure diagram, benzene is aromatic.
yeah. If it's connected to a carbon outside the benzene, then it is the benzene ring is there, but still the alcohol is not aromatic.
Okay.
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 Now the another method for the preparation of alcohol, it's a very famous method, and many compounds can uh, come in this category where you do the reduction. So Karthik, what do you mean by reduction?
Reducing something.
Yeah, so what you do if you are reducing something?
Sir, we add oxygen.
No, oxidation. Oxygen is oxidation, okay?
Yes.
So what else? It's not addition of oxygen. Imad, Ryan,
Sir, is it hydrogen in presence of Pt?
yeah, it's reduction. It's addition of hydrogen
Yes, sir.
by reduction. Reduction means, in simple words, oxidation means O is sound of O is coming, so OX. So it's addition of oxygen, and reduction is addition of hydrogen. Okay. So you need to have oxygen in the molecule, which is doubly bonded, and you put hydrogen, it turns into a singly bonded oxygen. And that's what reduction is. Catalytic hydrogenation reaction. Okay. So it's very simple. You take a compound which is already having doubly bonded oxygen. Double bond O is there. So what this compound is, what this functional group is known as? Imad, Anushka, Rayan, tell me. What this functional group having double bond O? As of now, we are seeing the functional group which is having single bond of OH. Now we are looking at doubly bonded oxygen. Okay. So what we are going to take, we can take hydrogen and we can take some catalyst. Catalyst can be nickel or ranite nickel, also it is known as platinum, palladium. Actually, these are the metals. They help to break the double bond easily. Okay. Right. So this is CH3, CH, and H and OH. Okay. So double bond was already there. So half of the thing was already set. Actually, you just bring in the hydrogen on both the atom, but you needed catalyst. The catalyst will help the help in breaking of H2 bond, and the hydrogen got attached to both the doubly bonded carbon, and the double bond changed to single bond. That's what the reduction is. Is it clear?
Yes,
So
sir.
which functional group is this? Karthik, can you tell me which is this functional group?
Yes, sir. Aldehyde.
Aldehyde. Aldehyde, the double bond is there, and one side, at least on one side, you have hydrogen, another side is carbon. That is aldehyde.
Yes.
Imad and Ryan, is it clear? What do you mean by aldehyde? Double bond.
Yes, sir.
One side you have hydrogen, another side you can have hydrogen or carbon. That's it. No other atom. No oxygen, no nitrogen, no chlorine. Because if you have oxygen, nitrogen, chlorine on other side, that is different function. So aldehyde, you take and you put hydrogen. You need to heat also, heat and apply pressure. Hydrogen is taken under pressure, and that helps hydrogen to get attached to double bond. And this is ketone. Ketone is C double bond O is connected to carbon. Okay, and if you have ketone, a hydrogen will get attached on both the carbon and oxygen. Okay, HH will get connected and you will have alcohol. So aldehydes, upon reduction or catalytic hydrogenation, I'm putting it in words. Sometimes only the reaction will not help. You should have the language in your mind. The words can help you to recall the reaction. Okay. So in aldehydes, you are going to get either primary alcohol or methanol. Aldehyde, the general form of aldehyde is RC. R is any alkyl group, and this. And if you take a ketone,
So 2 degree.
yeah, two alkyl groups are already there. You just use catalytic hydrogenation, and you have CH and OH, right? So it is a secondary alcohol. Okay, is it clear? So you take hydrogen, put it along with the aldehyde or ketone. So this method is, but with catalyst, definitely with catalyst, and under pressure and heat, the hydrogen molecule get absorbed on the catalyst and they react. Is it clear?
Yes, sir.
Okay. Now the next thing is there are another ways of adding hydrogen. Okay. And what are those ways of adding hydrogen? They are by using hydride donors. The other reducing agents are, they are very famous. LiAlH4. Let me write the formula.